Thank you, everyone who is here for joining us. This is InOrbit Connect Live, where robots and users meet. We have a very full day today, so I really want to get things going quickly here. Let's bring up the agenda today. So our day today is going to be split into two parts. We have a 2-hour-long session here. For the first half of our day, we're going to be having an expo showing some really great robotic and technology solutions. And then on the second half of our agenda, we're going to have a really fascinating panel discussion. So there is a lot to get through. I'm really excited about it. But the idea here is to talk about automation solutions and robotics and technology as it applies to supply chain and logistics. We have some great panelists and presenters here today and some really exciting technologies. So a few quick housekeeping notes. I wanted to make sure that everyone was aware we are recording today's event. So if some of your colleagues weren't able to join, we'll follow up later. You will definitely be able to share this with people or reference back for, for posterity, for future reference. But that's one. Two, unfortunately, one of our presenters today had to bow out at the last minute. So unfortunately, we will not have Relay Robotics presenting today. But of course, as with all of our presenters, you guys can reach out to us and we'll be happy to connect any of our attendees to any of today's presenters for further conversations. And then 3 questions. We are going to be taking Q&A from the audience. So if you'll see on the bottom of the Zoom interface there's a chat bar. Please feel free to type any questions you may have for any of our presenters or the panelists today. And we'll be taking briefly taking questions after each of the presentations today. And then we'll have a fair bit of time at the end for your general Q&A about where we're at. I think that is all I have in terms of our notes, housekeeping. That's great. So without further ado, I really want to jump right into our first presenter here. We're going to be showing the Kärcher B50, great robot. And I'd love to introduce Felipe Garcia Lopez, the manager of robotic systems and software at Kärcher. And Felipe, great to have you back. I will be back in a few minutes with any questions from our audience. Thanks, everyone. I'll see you soon.
All right. Thank you. I hope everyone can hear me. I'm going to share my screen, my presentation. So great. I think everyone can see me. So thanks for the introduction. It's a pleasure to be here. As always, Kärcher is, I would say, a long-term friend and partner of InOrbit. So it's always a pleasure being here. For those who don't know, Kärcher is a cleaning expert company in terms of cleaning equipment and cleaning services. We are active all over the world, in more than 80 countries, and we have today more than 15,000 employees all over the world. And of course, we do a lot of cleaning and cleaning equipment, but we do also cleaning robots for consumer households, but also for professional cleaning applications. And the Kärcher B50, which I will be presenting for you today, is one of our professional robots. So that's a scrubber dryer robot. So it does wet cleaning and sweeping and vacuuming, of course. And it's a robot that has between 50 and 60 liters of water, and it cleans. Our main target group is shown here. It suits this event here. It's supply chains, logistics, production environments, warehouses. But also, as you can see here in the image, we're active in airports and even office buildings, larger office buildings, and for example, also shopping malls. The robotics technology that we have here is fully developed in-house at Kärcher. We have a large team of roboticists in this company, and this is a product that's been in the market for now more than 12 months, and we are in more than 20 countries already with this product. To give you a bit of an idea, I hope you can all see the video. So you can see the robot a bit in action. So the main USPs for this product are that it's we take a lot of effort in having it certified in terms of functional safety and data security and data privacy, because that's a robot, like most of the robots, has a lot of sensors. I will show you a bit more details about the sensor setup of that robot later. But for our customers, it's important that the data is secure, that we take in the environments. And of course, the product itself, it has a full autonomy promise. We have a docking station. We'll also show you a bit more detail about that in the next slide. And it's a very maneuverable robot. We can recover from stuck situations, evade obstacles and all that, as you can see also in this video. And we put a lot of emphasis on an easy deployment. So we have a large display in this machine. So everyone literally can use that robot, set up new routes, new missions in their environment. So of course, there's technicians that do a setup and training for our customers, but the machine is designed to be very easily used in different environments. As I said, it has a full autonomy promise. So this machine comes with a docking station, and not only do we charge batteries, but also we release the dirt water that the scrubber dryer carries, and also we do tank rinsing, and of course we also charge fresh water. And with that docking station, it's really possible to have that robot running several days. Most of our customers use that all week without any human intervention. So the robot does a mission, comes back to the docking station, recharges the resources needed for the very next mission, and then carries on. Yeah, in terms of cleaning technology, I'm not sure how interesting this is for this audience, but of course it's a typical Kärcher cleaning tag. We have a pre-sweeping function for coarse dirt, and you can see in this animation how the cleaning technology works. But this is not, it's special Kärcher technology, but not special for this robot alone. But we have also manual machines that have that technology. I already talked about the certifications that this machine has. We take a lot of effort in certifying the robot to the latest or to the highest standards in terms of functional safety and data privacy. As I said, this is something that is very important to our company and to our customers. In terms of the sensor setup, we use a combination of different sensors. We have LiDAR scanners that do functional safety and do part of the mapping, part of the obstacle avoidance. But also we have 3D sensors that do also obstacle avoidance and perform obstacle mapping. Also equipped, we have ultrasonic sensors for detecting glass, and as you can see, I find it, for example, in shopping malls. For production environment and warehouse, it's not that important, but for like I said, for retail stores and shopping malls, it's an important feature. In terms of our after-sales success management, we're relying heavily on a fleet management based on InOrbit's platform. This is something we established already a couple of years ago because we knew we produce these machines, we push them out of the door, and then our customers need to take care of them. Of course, we have service technicians that can look after these machines, but it was clear for us from the beginning that we have a large fleet of robots in different countries, and it's a complex machine, it's complex environments, or there's a high variety on environments that our customers will use that machine in, and we need a lot of data to continuously improve that machine. And that's why we rely on that platform. We do a lot of analysis, performance analysis of our fleet. We also do remote interventions when there's a problem electronically or even in the software from the robots. We can do remote interventions when there's blocked paths or something like that. And of course, we have, if we want to, extensive logs from the machines to to do root cause analysis. And that for us, this is, I really have to say now, being 12 months plus in the market, a game changer, also compared to other products at Kärcher. So we have a high transparency on what the robots, do, what are difficult situations where we need to improve, for example, our navigation capabilities, also have a good feeling about, the usage of that machine, how often are they used, and in what situations and what times of day and all that. This may be also an interesting part. I have, those are videos from our lab here. This is an ever evolving software that we have. So compared to other products, at Kärcher at least, but probably also in other robotics applications that are, we do regular software updates. We continuously improve the capabilities of our robots. This is just one example, and I think I picked it because it suits to the production warehouse supply chain environment where you have a lot of forklifts. When we got in the market, we didn't have any forklift detection, and we got in a lot of trouble because of that. You can tell people to avoid forklifts only for so long. It will happen that the robot encounters forklifts because other than, for example, AGVs or AMRs that do transport tasks, we don't have like a single route. So we want to cover area. It's a lot harder for us to avoid small obstacles in the environment because we want to cover every free space in the environment to clean it. And this is a very good example based from the data that we got, for example, from InOrbit or via InOrbit of our robots, of the situations that are in. We could improve our software in a way that we can now really very well detect even very small forklifts. And this is a software feature that we shipped in the spring to our fleet. And this is a very good example, I think, for the target group that we are today talking about.
That's amazing. Felipe, I think we're cutting into our question time. Do you have one more point you want to make here? Yeah, that's the last slide.
Absolutely. Maybe, sorry. Yeah, in terms of transparency, also for our customers, we have a web portal, specifically also defined for our retail customers. But there's also Kira V50 is InOrbit Connect certified, as you can see here. So it's also a possibility for our customers to, if they have more than just Kira robots, but also other robots in their environment, can also, when they run an InOrbit, you can also link our robot in there. And which is also a huge topic lately. I would even say the whole year already for us when we talk to customers is orchestration, or at least connectivity to standard interfaces in terms of, for example, VDA 5050 is in Europe a huge topic. But what is meant here is standardized infrastructure and master control for fleets of robots in production environments.
Yeah, absolutely. Well, and I guess to that end, obviously we're very familiar with InOrbit Connect. Anyone who is on the line may not be familiar with that program. We might be able to get into it later today. That is the framing of today's event as well. But we'll certainly get to that as we can. Just one quick question. So can you give me some specific examples around orchestration that you may have encountered with this product?
Well, I mean, what happens a lot is that we encounter other robots in the environments we're operating, and it's always a problem avoiding collisions with highly dynamic obstacles in that environment. We have a lot of crashes with other forklifts drivers, so that happens a lot. So and also with other, it happens once or twice that we had at least, I wouldn't say collisions, but maybe touching other robots that were active in the environment. And you can always see that there's a lot of stoppages that are unnecessary when you don't have orchestration. And the second thing in that regard is that, as I said, now we have robots in, I would say, every large logistic company already, or supply chain company, and they all want to have some kind of a master control interface for these robots. So VDA 5050, as I said, is a topic with every customer, as we experience now.
Absolutely. Okay, well, thank you so much for your time today. I know that was very brief. Of course, again, if any one of our attendees wants to know more, feel free to reach out to us. We'll be happy to connect you to the Kärcher team. But I think it is time to move on. Thank you so much. So what I'd love to do next is bring up our next presenter. So this is actually going to be really cool. I spent all morning watching this robot run upside down and this amazing AMR goods to person system. I'd love to introduce our next presenter, Igor Anshushkin, the founder and CEO of Instock. Igor, can you come on, please?
Hi, guys. Pleasure.
Hello.
Can you hear me now?
Oh, yes.
I apologize for the background noise. The only way to participate, and I wanted very much to participate, for me was to take this call from the client side, and it's a peak of their fulfillment. So sorry, like if you hear all of those forklifts, bear with me. All right, so I would like to present you the Instock robot. We have only one robot, and that's why we are not inventing any special name for it. It's just Instock robot. And the problem we're solving is in the realm of what's called goods-to-person systems. So you probably everybody knows that the bedrock of the modern fulfillment of the modern e-commerce is how you store stuff. It's a storage technology, and how you fulfill, how you pick, pack, and ship. So the evolution previously was that people started from manual processes and then went into some kind of pick assist and AMRs robot. But the most efficient are goods-to-person robots. They use the full vertical space of your building. And the historical problem with this segment was very inflexible solutions and narrow efficiency range and high cost. So that's where Instock comes in. We spent 14 years in the e-commerce fulfillment, delivering for world's biggest retailers. And we had experience working with many solutions. My team, for example, deployed the very first micro-fulfillment site in the world for grocery. And so 3 years ago, we went back to the drawing board, and we're thinking like how to solve some of those challenges, where they're coming from, what's the root cause of those things. And we came up with a system that we think that the root cause of many problems is that the way people address three-dimensional movement was mostly through some kind of gears, pulleys, rails. Those elements require very tight tolerances, and therefore those tight tolerance requirements, precision requirements, they proliferated upstream to manufacturing. Everything becomes more complicated. Manufacturing, installation, reinstallation, you need special people, technicians, and manufacturing partners. So that's what we solve. Our grid doesn't require it doesn't require much of the precision in manufacturing. It's a fully static structure where robots are using permanent magnets to drive on floors, walls, and ceilings. And you see that robots, they drive on those surfaces more like a car is driving on a road rather than a train driving on a rail. So the dynamic magnetic suspension system of the robot, it adapts to imperfectness of the surface, to so small ridges, gaps, and steps. And so no tight tolerances are required. That's how we can lower down the cost and deliver three-dimensional goods-to-person functionality to customers at significantly better price point. And the major factor behind the lowering the price point is reducing complexity of everything. Again, due to background noise, I will not go for too long. I wanted to show you the robot, so I have it here right by my side, but I have this background that is imposed by InOrbit. So I don't know, guys, if you can switch it off, I can turn my camera and show the robot, but otherwise, I would have to do it from the video presentation. Then, okay, if you would give me 1 second, I would launch a demo video. And so this is a video from our QA lab where we test the robots. Here you see the last generation, the one that goes into production. The robot positions itself on the top of the bin, picks up a bin, moves it into the bin shaft, gets bins through the bin shaft to the lower levels. The big differentiation between Instock robots and all other solutions like AutoStore, Exotech, Fabric, Robotics is that we are working and we have in our architecture this big promise of self-service. Our robots weigh only 100 pounds. Our customers can deploy the robots themselves. They can receive, unpack, let the robots into the grid. Everything happens on the ground floor. You don't need any special jigs, tools, or mezzanines to deploy the robot, but they also can send the robot back. And that capability of self-service, it opens up the possibility for as a service model, because now you can share the robots between customers. Let's say you anticipate more traffic, more sales next month, and some other customer, or we have robots in the Instock depot, so we have robots elsewhere. So those additional robots can be sent to you. You will receive and unpack them themselves and deploy into the grid. Reliability and self-service are two core components, we believe, to enable very efficient robotics as a service at the right price point. So you don't need technician on site. There are self-service protocols, how you can resolve most of the situations, and you can deploy more throughput capacity or scale up, scale down throughput capacity whenever is necessary. So that's Instock in a nutshell. Happy to answer your questions. We're looking for the day, of course, when we will connect Instock robots to the shared platform, where we can see our robots in conjunction with other robots that may be, for example, doing piece picking. I mean, we love human associates, but we anticipate also the day where the piece picking robot will be picking from the bin that is inside the grid to the bin that is on some other robot. Instead of the table that you see here, some other robot may have that bin and drive away. And then those robots should kind of have at least connect to the same interface, same system to talk to each other.
Well, that's sort of the basis of all effective RobOps, right? Hey, Igor, I had a question for you. I by the way, I love this robot. I just can't help watching it go upside down. It's just so cool. But let me ask you a question. I think I saw an interview where you said Instock is the most flexible system out there. I think on your website you even call it elastic. Can you talk a bit more about what that means to you guys?
Absolutely. So you see, we decoupled robots from the grid, from the environment, to a maximum possible degree, right? So everything that is bolted on the floor, that is simple, static, and cannot break. And the robot is a true AMR, right? It's using those fiducials to localize itself, find its way to the charging stations, and if necessary, even come to the exit of the grid. So we are the only company where the robot driving space and the storage positions of bins, it's the same space, right? We don't have predefined storage positions. We can optimize storage to throughput ratio because, again, it's the same space, and these two parameters are always in counterbalance, right? The more space you've taken for storing stuff, the less space you have to drive for driving. So we can balance these parameters even post-installation, which other companies cannot do. So this flexibility of simple static infrastructure, AMR robot that customers can deploy themselves, and ability to tune parameters post-installation, that's what brings flexibility.
Wow, that's great. Very cool, very cool. So thank you so much for sharing with us today, Igor. We really appreciate your time. And again, If any of our attendees have any questions about Instock or their amazing system here, please feel free to reach out to us. We'll be happy to connect you. So with that, it is time to move on to our next presenter. If you're new to this space, well, get ready to hear about this company quite a lot. Up next, we have the good folks from SICK here presenting some really cool technology. I think you have 4 products on deck for us to look at today. And with that, I'll turn it over to Brian Sellers, the industry marketing manager over at SICK. Thanks, Brian.
Yeah, thank you so much. I appreciate it. Good morning, everyone. Good afternoon, wherever you are. Hope things are going well for you. I just wanted to do a little presentation for you, and if I can get this going here, hopefully I won't take too much time to do this, but let's see. Here we go. All right. So yeah, so just a couple of things that that we wanted to talk about. There's I hope everyone can see the presentation version of the presentation. But so what we're doing here, actually, you know what? Let me just make sure. I apologize for this, y'all. This is not my forte. Let's see. Here we go. All right, let's do this fun. Okay. So what we're going to talk about today is just some of the latest trends in LiDAR and ultra wideband technology, and really it's just talking about the AMRs themselves. Localization or tracking for AMRs, AGVs, things like that. Of course, SICK does not make any of those products, but we make the technology, or not we don't make the robots, but we make the technology to give these things some autonomy. So, where did we all start? So we started with, back about 20-something years ago with this very simple rotary LiDAR. And since then, you can kind of see the progression as we've gone over the last couple of decades here. Different shapes, different sizes, different features, human-rated safety LiDAR, multi-layer LiDAR, and everything like that. And so you kind of get an idea of, we've been doing this for a minute. And of course, we've always been in the industrial area. We're not into the automotive sector. We're not trying to get into the self-driving car market, really just staying into the manufacturing, the industrial side. So for those that may not be familiar with how LiDAR works, here's just a brief kind of little animation for you. So we're using time of flight laser, which basically says, okay, how long does it take to get from the sender to the target and back? We're using that technology, and we're using it in correlation with a rotating mirror. And so whether it's 180 degrees like this is showing, whether it's 270 or 360 even, it's all the same type of format. You're basically sweeping these lasers around, and you're using that to build your area that you're looking into. From that, there's always been kind of the idea of, I've got a moving target, I've got a moving product inside of the LiDAR. And anytime you have something moving, mechanical movement causes heat. Heat makes products kind of break down over time. And so the next kind of golden grail, if you want to call it that, holy grail, is this idea of solid state. Solid state being there's no moving parts, you're just using pixels. And then this also, with solid state, gives you a 3D type of field of view. So you can see there on the left, there, this SICK Visionary T is using, again, an array of pixels. You're looking in the X and Y direction, but you're also looking in the Z direction, forward and backward away, and towards the LiDAR unit, so you can kind of see that 3D section there. Now, the latest, I would say the latest advancement of that is actually making these human safety rated. And so we can use these on AMRs, AGVs, but then we can also use them in industrial robot cells as well, to kind of put a 3D cone, if you will, over the robot cell, which is a new feature for that. So what is this data doing? Obviously the LiDAR can use the sensor data just to measure its environment. It can also do localization, which I'll get into a little bit more, where you're actually comparing the measured data with a map that has already been preloaded into the bot, and then you can determine position based on those measurements. And then, of course, navigation. I mean, the LiDAR is one of the main ways to tell the bot where to go, what not to hit, that kind of thing, whether it be a person or whether it be a column. So again, getting back to localization, that's not new. Localization has been around. LiDAR localization has been around for a long time. It has traditionally used what I would call reflectors, or something that you put into the environment. And as long as you get three reflectors, if you will, you've got the means to do triangulation. And so the bot knows where it's at. Well, the kind of that's morphed into being able just to use natural contours in the environment, not having to depend on, additional items that you as a customer have to add, or you as an OEM or an integrator have to add into the environment in order to localize. Now you can just use contours that are out there, shelves, columns, pallets, whatever it may be. The nice thing about that is if you ever have to move something like a shelf or a column or whatever, it's not a big deal. You can just kind of reteach its environment, and it'll pick up as normal, just as if it was working before. So you kind of move from LiDAR. Now we're moving into kind of the next phase, which is ultra wideband. And again, it's not really new, but it's in the industrial area, it's kind of new. So if you imagine taking a bunch of anchors that you're putting into the environment, and then you've got these tags that kind of do the localization for you. And so the tags could be on the bots themselves. They could be on the assets. They could be on things like, like you see there, like a little tote or something like that. So you can actually not only track the bots, but you can also track the totes themselves. And the nice thing about this is line of sight isn't as crucial because you're putting out those waves out there. And so, line of sight is like LiDAR can't look around the corner because you're using laser light. This is not that susceptible to that because you've got the tags kind of everywhere and they're always going to pick up. And so you're taking that tracking off of the bot itself and you're kind of putting it into the environment with the tags just being on the bot or the assets. And I like this just because it kind of tells you what you get with that. So if you look at we'll call it the three main bubbles we have: identification, localization, and then analyzing the data. Tag lock is kind of what we call our ultra wideband tag lock, kind of a blend of that. So what you're getting, which object is in the flow of goods or production. All right. Then from there, where that object is, and then you can use that data to actually understand the flow of goods of that, and then you can start trying to optimize that. And so now you're starting to get into the Industry 4.0 level, which is still, I would say, still in its infancy, kind of. We've been touting it for a while, but analyzing that data, taking the big data and doing something with it is the heart of Industry 4.0, and that's what we're really trying to get out of this type of stuff. So that's really all I had for you today. If anyone has any questions, or Jeff, if you'd like to come back on or whatever, that's fine. But I just wanted to share this with you today. So thank you very much.
Hold on, just muting myself here. Okay. Yeah, no, that's great. It's fascinating. And, again, for those, new to the space, Brian, we lost you there for a second. I lost your video.
Oh, sorry.
For those new to the space, SICK is integrated like everywhere. Like they're pretty much everywhere. So it's great to see. Quick question about the ultra wideband tracking. How many tags can you have in that field?
Yeah, good question, Jeff. Yeah, well, there is, but the limit's about 1,000. So it's a pretty high limit. We'll put it that way. But yeah, that's about what we're saying on these tags is about 1,000 per. They can be scanned at one time, if you will, or tracked at one time.
Mm-hmm. Mm-hmm. And
and we're actually.
I'm
sorry, I was just going to mention we actually hope to have this in display at your robot space there in Northern California here pretty soon.
Yes.
Yes. Yeah, we're getting some stuff to put in there, so we're hoping to have this on live and working at your facility here pretty soon.
Yeah, I'm really excited to get hands on this hardware for sure. Absolutely. One more quick question, if I can just squeeze it in really quickly. SICK especially, you guys make so many products. It's kind of swath, not just strictly in this AMR robotics space. You guys make a lot of products. how do you suggest people new to the space might go about sort of navigating where to start, especially with some of these things that you provide solutions to questions people might not even know they have until they really get into it?
Right. If you're talking about just like how to go about finding, the different solutions that we have or whatever, obviously the website, I mean, SIG.com is pretty comprehensive. You can break it down not only by technology, but then you can also break it down by the industry. So if you're in a certain industry and you want to see what kind of applications that we solve in that industry, you can just kind of follow that tree down to specific products and how we handle those applications. But yeah, the good old interwebs, man, that's the way to go for sure.
All right. Well, thank you so much, Brian, for your time today. And again, if any of our attendees here would like to connect with the SIG team, please reach out. We'll be happy to make that connection. And I'm sure we'll be hearing more from you soon. Thanks, Brian. And with that, let's move on to our next presenter, who is going to be giving us a live demo. This is very exciting. Presenting the InOrbit platform. I'd love to bring on board Florian Pestoni, the CEO and co-founder of InOrbit. Hi, Florian. Welcome to the show.
Hi, Jeff. It's a hard act to follow after all of these presentations, but I think what's interesting is how we can connect everything together. We saw different people from the ecosystem, and they each have their place there. So what I want to do is something that I would say is a little crazy, which is doing a live demo of InOrbit, and you'll see the focus is really on orchestration of different robots. So maybe just to get everyone situated, think of InOrbit as being the single pane of glass, one way to manage everything. So in this case, we're using a made-up customer called Brickmart. They're a retailer with retail stores and distribution centers around the world. They have over 100 robots. We're going to focus on one location, which is where I'm at right now in the robot space. Now, when you have a fleet that's distributed, that's around the world, you need to know what's going on with your robots. So InOrbit will give you a overall view of your whole fleet. If you're an operations person, typically you care about the robots that are not happy. So you can say, okay, just show me the robots that need attention, show me why they need attention. You can also drill down to individual incidents or to a particular location. That's exactly what I'm going to do. I'm going to focus on this one site, the robot space, which is here in Northern California and Silicon Valley. That's where I'm calling from today. And to prove to you that this is a live demo, I can show you, we have integrations with cameras. So this is me, hello, I'm waving, you can see me in the camera. So what we're gonna do is we're gonna create in this space a situation with multiple robots trying to carry out tasks in a shared space. And we heard from Felipe, for example, about forklifts, which if these were animals, I would say they're the natural enemy in the habitat of robots, manually driven forklifts. So being able to track elements like what Brian was saying is going to become critical. But for now, we're going to focus on these robots. And one of the things that we're able to do is put multiple robots basically on the same map. Now, of course, each robot will build its version of the map, very much in line with what Brian was discussing. So this is what this Mir 100, this is how it sees the world with its unique sensor package. If I switch to an Auto 100, it's obviously the same space, but it will see it a little differently. We have our little picking robot here, and it has its own view. But these maps are not the most human-friendly, so we like to use an annotated map that's a little bit easier to understand. You can see we're getting, a lot of data. We can see the LiDAR return camera view. So rather than go into the details of this, let's take a step back and, I mentioned this is a retail store, so let's go shopping. We're going to buy a couple of our hugely popular mascots, Orbito, about 3 of those. You go back. Oh, no, hoodies. Okay, some water bottles, maybe. 2 water bottles, let's say. So, of course, this is just a standard e-commerce website hosted by Square. I have this very special coupon. And now when I check out, a lot of things will happen very, very quickly. So when I place that order goes through a warehouse management system. And of course, there's a number of WMS systems out there. We're just using one for our purposes. So that order is now being picked up by InOrbit. And what we're going to see, if I'm not too fast, we'll miss it, is we see the robot moving towards that location. Let me give you a better view here. Before our helpful warehouse associate fulfills the order. So you can see there's a pick-to-light system as well here. Is using InOrbit on his phone to indicate that the order is complete. And you can see the robot is waiting for an item, and now it's moving on towards its destination. So we just saw a classic case of picking, where it's a collaborative effort between an associate and the robot. Now, you may have noticed that we were out of hoodies. So our system also dispatched a restocking robot. Now, here's the restocker next to me trying to go through the door. We also control the door. But check this out. We had both robots trying to go through the door at once. That would have been a disaster, right? So InOrbit can basically do traffic management across brands. So in this case, it was an intersection or a door. So it paused one of the robots while the other robot continued. You can see the robot is waiting for the single occupancy zone to be ready. Once that area is clear, this robot continues towards the back where the items will be picked. So I think what's interesting here is we had integrations with IoT devices like a door. We had integrations with cameras, integrations between different robots. And now when the robot arrives at its restocking location, you can see the pick to light here. That shelf is glowing orange because it needs some hoodies. And now Chris will fulfill that and goes to the tablet that's mounted on the robot and basically says, great, we've completed that order. So again, and the robots continue through their tasks. How are these tasks defined? So let's talk about missions. So missions is a way to define the robot behavior. And of course, we can integrate with its native fleet manager, but also we can define missions that are generic. And the benefit of that is now you can see the performance of all the robots across all of these different missions. And oh, oops, there's an alert here. It looks like the waypoint is blocked. So one of the things that you need to do is do problem resolution. So let's see what's going on. So you can see the robot is trying to get there. Let's see. Okay, looks like there's something blocking the way. Let me just pick this camera and Yeah, it looks like somebody left a pallet there. I really wish we had that ultra wideband tags from SIG already installed, because then we'd be able to know that something is there. But in the meantime, let me try and fix that. So in this case, I'm going to connect to our Auto 100 and tell it to go return the cart. So just to be clear, I'm not controlling the robot. I'm basically nudging the robot to do the right thing. So in this case, this is using Auto's native fleet manager and navigation. And it's going to go towards the, let me see, here's a better view. It's going to go pick up that, that cart, that pallet loaded with boxes. And I'm going to wait until basically the coast is clear and it's safe for the Mir 100, our restocker robot, to continue. So as soon as this moves out of the way, I think it's thinking how to get out of there. There we go. So as soon as this is out of the way, I can do, and I'm going to do it here from the UI so you can actually see it, but I'm actually getting alerts on my phone via Slack. So I could resolve the problem directly from Slack. But here you'll be able to see it. I'm going to clear the error that this robot has. And then let me, yeah, there. So let me retry that mission. And there we go. So the robot got to its destination. So I think maybe just as a quick recap, we were able to see some missions in real life. We were able to see things as they were happening, but maybe I want to go back in time to a few days ago and then look at a mission that was carried out by a robot. So because InOrbit is recording everything that's going on, we can now do, go back to a previous mission from days ago. We can see all the data about the robot, all the incidents, everything is correlated, of course. And then I love looking at the heat map, which shows me where the robot is spending its time. And one thing I can see here is there's this extra stop here. I don't know, like this is the shelf, this is the door, all of this makes sense. But I may want to go back and investigate why the robot was spending time here. Because that might be an inefficiency, and then that allows me to continuously improve the operations. So to recap, we saw content from all of these, interactions with all of these different robots all working together.
Yeah, that was great, Florian. I obviously think it's amazing. It's really cool to see, these different robots from different vendors working together. I think that people who are just getting into this sort of space, there's a lot of concern about how to approach, RobOps and orchestration of various robots. When you get into a production setting, you start small, but very quickly, once you start seeing success, our experience with all of our customers has really been, you start seeing success and immediately you're like, well, if my robots are working well picking, why wouldn't I add a floor cleaning robot? Of course, that just makes sense. So can you talk maybe a bit about InOrbit's approach to interoperability and how we manage that?
Yeah, of course. So there's all of these different use cases that could be automated. We saw even today, we saw the amazing work from Instock, but once that bin comes out, where does it go? There may be an AMR waiting for it. And then you need to keep that warehouse clean, right? So you can use a Kärcher robot for that. And we're not going to have one company build everything, right? Kärcher specializes in cleaning equipment. They're going to make this amazing cleaning robot. not necessarily an ASRS system, and conversely. So I think it becomes really critical to be able to not just have them operating in the same space, but also have consistent analytics across the board. And the way we do that is we're sort of like the Google Translate of robotics, right? So we're able to connect to each robot through its native mechanisms, whether it's an API or if it's a ROS robot, we'll run on the ROS robot. If it has a fleet manager, we'll connect to the fleet manager. So there's lots of different ways, but then you have this consistency of view. So this allows the ecosystem to develop more, where each company is focusing on what they do best. But as an end user, you can get the best from everyone and put it together for your needs.
Yeah, absolutely. Absolutely. And I think really that, when you were going through the mission analytics in particular, and by the way, everyone, this is brand new. We have a press release going out next week about that. So you're getting a little preview of it. But, that it's so powerful to be able to see, your multiple robots in the same analytics dashboard, compare them over time. It's just a really powerful orchestration tool.
Yeah, I think we're pretty excited, and I think there's many. Felipe was mentioning about VDA 50/50. We actually support VDA 50/50. We support mass robotics. We support open RMF. So these are emerging standards that are out there, but they tell you how to talk to the robot. They don't tell you what to do with the data that you get from the robot. So I think even with a VDA situation where InOrbit is a master controller in VDA speak, you can still mix and match. So let's say not all your robots are compatible. You can bring a robot, even a legacy robot, and integrate it with your new VDA-enabled robot. So that idea that you can have that technical interoperability that's emerging, and we're contributing to standards, we're making open source contributions. But regardless of all of that, which some of standards move fairly slowly, you can already do a lot of this today.
Yeah, absolutely. Well, actually, I think that that leads us quite naturally into the next portion of our day today. I think we should switch gears. We're going to go on to the discussion panel portion of our event. And conveniently, Florian will be the moderator for the upcoming panel. So welcome again, Florian. But today we're going to be looking at robot operations in supply chain. And I'll leave Florian to introduce our panelists and have a great time. Should be an interesting discussion for sure.
Fantastic. The bad news is you're still stuck with me, but the good news is we have some really great panelists presenting today, joining us for the discussion. I'm going to introduce them quickly, and then we'll jump right into some interesting discussion. Let me start with Florian Schebinger. Yes, another Florian. He is the head of Kärcher Innovation in the Innovation Hub in Silicon Valley. He's focusing on startup partnerships and investments for Kärcher New Ventures, which is the corporate venture unit of Kärcher. And again, you got an intro from Felipe about Kärcher being the world's leading provider of cleaning solutions. And they work for commercial and private customers. A lot of people may have like a Kärcher pressure washer in their home, but now you've seen how they're participating in the robotic space. So Florian has been with Kärcher for over 9 years, different roles from in-house consultant, business development, moved to Silicon Valley in 2018 to found the company's activities here. And he holds a master's degree in business administration from the University of Stuttgart. Let me introduce now Parth Pithani. So Parth is really a warehouse robotics enthusiast He's currently the director at Kärcher.com for robotics and has been really on both sides of the table, both selling as well as using warehouse robot systems. So he has this like very unique perspective. He's also really, really passionate about enabling robots in the warehouse and educating people. Very active on LinkedIn. You should definitely follow Parth, as well as his website, Warehouse Robotics. It's WHSErobotics.com. Where he shares his insights. Really, there's always something new to learn, and Parth is usually a couple of steps ahead. And then lastly, but not least, Nicholas de Kaiser, who is with Boston Dynamics since 2019, where he joined to lead the company's sales and business development efforts in logistics. He's building a team to actively sell and support Stretch, which is the company's mobile case manipulating robot. So Nicholas has been in the robotic space for actually some time. He spent 13 years at ABB Robotics, where he held several international business and product management positions. He's also a bit of a citizen of the world. He's lived in China, in the USA. He's originally from Belgium, and he holds a master's in applied economics and international management from the University of Antwerp. So with that, I'm hoping we have everyone joining with their cameras on. Let me jump into the questions. And why don't we do this? Why don't we start on a happy note and ask maybe each of you in turn to share examples of successful robot deployments in supply chain operations. To the extent that you can share, maybe a couple of minutes each. Let me start with Parth, since you've seen it from both sides.
Yeah, thank you, Florian, for having me. Thank you, InOrbit team, for having me. I think for me, pretty much the success stories comes from the warehousing world, where the order fulfillment space has seen a lot of adoption in terms of robotic systems that can really help with the most labor-intensive process of the warehousing space, which is the order picking solution, order picking activity, which takes almost 55 to 65% of the labor cost. So labor cost being the driver and the labor availability being the biggest pain point within my world, which is warehousing world. I've seen the adoption being too much in the order fulfillment space. And from a use case perspective or the success perspective, I have seen a lot of success within my network as well. We have robots in one of our warehouse where we are shipping a good amount of volume using robot shuttles, mini load sorters, mix of robotics, flexible automation, as well as mix of inflexible but an automated system. So definitely a great potential that I see there.
How about Nicholas? I know you started with trailer unloading. Anything you can share there?
My bad, I was still muted. So in terms of, I can certainly talk a lot about that and happy to do so, and I'll probably plug into it throughout our conversation. But if I think about like really proven success, to what Parth was saying, you think about the order picking at item level and robot assisted order picking. I mean, that has certainly taken off and it's something you can start to see in many warehouses you walk in. I would say not most, but in many. Well, before you would walk 10 years ago, you're walking into a warehouse, you'd be lucky to see anything robotic, right? So I think that's where you start seeing repeat means, there's clear adoption. And I think one of the enablers there was really the ease of use of that. There's a lot that goes behind that, but just the fact that you have these robots now that operators with no degree, with I would say high school education just will operate those robots like in their daily life. It's amazing. And if you then stretch that forward, or look forward, like in what we're doing in trailer unloading, I mean, that has definitely worked very well. We only started deploying this year. We actually announced today that we picked over 1 million boxes. So if you go on LinkedIn, you may see some of that from Boston Dynamics today in the news feeds. And so you could make a case that, for year one, multiple sites, that many boxes picked. Yeah, it's starting to be an actual successful operational success. So we're very proud of that. But one of the builders that I find there is that the ability to understand boxes. And that has been going on for much longer. And I think that's where, 2D, 3D, machine learning behind all of that. It's not just for order unloading trailers, but just to move around boxes in a warehouse. That piece of technology also has come so far in the last 5 years that it enables it and gives you an operational utilization of that.
Yeah, and we're going to get into that in a minute. So, Florian, great name, by the way. I'd like to hear from you about successful robot deployments, specifically in supply chain operations for Kärcher.
First of all, thank you for having me today and for setting up this great event today. And I'm happy to share some insights from the Kärcher world. And yeah, when you talk about warehouses and logistics, it's definitely like the cleaning application is definitely not the key application there. However, it's a crucial one to make sure that there's like a safe operation, right? Possible. And as Felipe mentioned earlier, that we've already deployed robots with the major logistic players, especially in Europe. And yeah, the logistic and warehouses target group is very important to us because the robotic is like already further advanced in this vertical than with others. So like robotic is not new to them. So for us, coming in with cleaning a robot is just like an addition to their robot fleet, and therefore it's like a very important vertical. And also like we've seen some success stories there already. But as we're still ramping up our sales there, it's still at the very beginning.
Yeah, I think visiting, for example, ProMat this year, the number of applications of robotics in logistics and warehouses is really exploding. So let's talk a little bit about the benefits, but also the challenges when you try to integrate a robot into a supply chain. Maybe Nicholas, back to you about like your comment about understanding boxes and understanding the environment and some of that progress. What does it unlock, but also what are the challenges that had to be overcome to get there?
Yeah, so I mean, if I go back to basics of robots and moving boxes, I mean, robots have been moving boxes for many years. If you go to a factory and you see how boxes are being palletized, happens. It's it works really well, but it's all programmed. It's at the time there was very little vision. It works, the boxes are the same. We pack, we make a nice pallet, move on. Well, in the warehouse, unfortunately, that's not reality. And so being able to deal with new scenarios every single day, you can't reprogram that. And so that's where the vision technology, the machine learning behind it has made such big leaps in the last, I would say, you could probably look back at last 10 years, but in the last 5 years, it really has started to become usable. Like if you think 10 years ago, yes, we had some nice technology that could kind of understand all the boxes, but it wasn't really, it was buggy. In the last 5 years, it just works. And so it's almost, and now it's almost like an afterthought. Like, of course, the robot can find all the different type of boxes, and of course, it's going to pick it up, and of course, it's going to be able to place it somewhere. Although the placing part, I think we still have a little bit of work, but that is just remarkable, because now you take away one big piece of a big hurdle of putting it in a more flexible environment that now, from a technology standpoint, has become, I wouldn't categorize it mainstream yet, but at least well established enough and easy enough to use that people us as a company can rely on it. We develop it ourselves, but other companies are relying on third-party vision tech to be able to enable more applications in that field. And then, of course, you get adoption when multiple people are solving the same problem.
Wonderful. So Parth, I've been reading some of your content for a long time, and I love how you're optimistic, but you also keep it real. And you talk about some of the real world challenges that are not always technical when trying to deploy robotics in logistics and supply chain. So can you touch on some of those challenges?
Yeah, I was actually writing down the challenges. So I think let's start with on a good note, right? As you said, benefits. Of course, there are benefits with robotic systems, right? One of the primary benefits, if you have to thinking from a 30,000 feet view level in a warehousing space specifically, it's just the less dependency on labor fluctuations. We need humans, we need people in the warehouse. There are tasks that we cannot do without them. But at the same time, the dependability on pushing out your orders during peak, during your sales and everything, dependency decreases, which is useful because it helps with faster order fulfillment. It also helps with labor cost. Of course, you get less dependency on the labor. Overall, just improves efficiency and accuracy. So there are good stuff around that. But at the same time, I think the challenge is adoption challenge. I think that the way a few bullet points actually I wrote down was like, not everyone is ready for a robot. The maturity curve of each and every warehouse is at a very different level, right? So basics are the way I look at warehousing world is 5 different stages of maturity curve for each warehouse, and your 4s and 5s are where you really start seeing robots really providing value, warehousing being ready for using a robot. But everywhere else is we do not have the right systems, we do not have the right processes, right people to take care of it, strong maintenance team, strong designing team, strong engineers. So for me, from a challenge perspective, I think it's a step-by-step processes, but the biggest challenge that I see is the adoption challenges where the sites are still not ready yet to fully harness the benefits of robots because they still have small kinks to work around and small things to fix. So, and one classic case that we just mentioned about that it's not always about the robots, how great they are, the AIs and the MLs is. And to your point, it's true. Like if I had to give one person just making sure they are able to take care of that poly bag that my robotic arm is not able to see, that's okay. But if it's able to see everything else, that's great because that I'm still taking a lot of work, which I would either rely on a human being to do that, where I don't have people to do the work.
Absolutely. So maybe switching to foreign, I think when Felipe was presenting, he was kind enough to admit some of those close encounters with robots. This is something that is not too many people talk about, but it's really widespread. There are a lot of stories about for example, manually operated forklifts. I think they're the apex predators in warehouses. So if you get in front of one, it's not gonna end well for you. And I think it's getting more complicated, right? Because now we have forklifts and we have picking robots and we have cleaning robots and we have inventory robots. So there's one aspect is how do we keep track of all of that? But the other is how do you turn this environment into something where these robots can operate safely and efficiently? So Florian, I don't know if you have any perspectives on some of those challenges.
No, absolutely. I mean, I think I didn't want to touch on the benefits anyways because they're obvious here, right? Like it's like with robotics everywhere, labor shortage and stuff, and we don't need to touch too much on that. And you brought it up already. So I see the biggest challenge, and I would put it under the headline integration, like to every extent, like integrate. Because if you're like as a company, you're like you get into robotics with like AMRs, so you consider this as a silo. Then if they're like, okay, at some point, like, oh, good experience with a robot, let's bring a cleaning robot. It's another silo, right? But like it's impossible to consider this like as a silo because at some points they're gonna interfere with each other, and that's where you have the problem. And you can even go beyond that, not just between robots, but also like there's still gonna be manually operated machines. And another level, like integrating into the existing processes. So that's like there's different levels of integration that's going to happen and have to happen. That's where I see the biggest challenges, and that needs to be tackled. And especially like from a Kärcher perspective, I mean, everything we want like is not to interfere with the actual operations of a warehouse, right? We are kind of like a support function, again, a crucial support function. But like if we like screw up operations of the AMRs and the actual value creating applications in a warehouse, like we are kicked out immediately. So for us, it's important to like, and that's again why we are like within InOrbit, because we see this as some potential to get into or like to integrate with other robots and the warehouse operations in general.
So let's stay a little bit on that, and with you, Florian, because I like to say, modern robots are data machines, right? So they're both driven by data, through these integrations. They also generate a ton of data themselves, right? So I guess, how can you, there's a lot of, digitization or digitalization, depending on what side of the pond you're in. A lot of talk about it, but how can we use data and analytics to optimize these like robot-driven supply chain processes? And again, this is like a data fire hose. How do you deal with all that data? And Florian will
yeah.
you can continue.
Yeah, of course. I just can I mean, like right now everything is about AI. All is about AI. Like we started with AI background, got funded more or less, and but we had this discussion already. Like it's about like not the algorithms, it's about the data, right? And we can throw out some buzzwords, and the data is the new gold, and whatever. So I think like we're still at the very beginning where we collect the data. So we have to actually collect that and in order to become in a position to draw conclusions here. And of course, like the objective is to further increase efficiency and make everything better. And like in our case, I can immediately think of like an example is like that at some point you can predict like where you have to clean more and where you have to clean less, just because of like based on data. And historical data. So that means, okay, maybe I need to go into that corner like more often than to the other one. So we like interfere less on this side. That could also like, you can also draw conclusions about like the usage of the warehouse in general, which is not just only about cleaning and everything. So I think this is still needs to be figured out what it's gonna be and what the future application is gonna look like and conclusion. Well, I think right now it's most important to get the data. So I think that's the stage where at least we as a company are.
Nicholas, maybe over to you. How does Boston Dynamics use data to improve warehouse operations?
At many different levels, evidently. There's the data. There's the data of at the carton level itself that we're using, and I talked about that earlier. When it comes to, you talked a little bit more about safety and going around the warehouse. This is still work in progress for us. I think, as Florian was saying, there's a lot of data gathering, understanding what data we need. But if we go and maybe take a step further, like how is this going to be useful? When you roam around a warehouse with a robot, there's a lot of safety implications. How can you? Is there ways that you could like parse out the warehouse? Are there areas that are more robot friendly and some that are more people friendly? I mean, ideally, you don't have to worry about that, and it's all just one nice orchestrated thing between robots and people. But I think that I do think that we may have to take some steps there. There's a few practical considerations in that aspect where just data and sensors may not necessarily always be the answer, and sometimes there's just common sense that we need to bring into this. So that's a little bit less scientific, but I think it's you probably hear that a lot. But if you go and compare that with self-driving cars, for instance, where there is also a certain level of common sense that is expected from people when they operate a car. Well, we would want to see some of that some of that worked into some of the workflows in the warehouse, because that would allow us to probably get with some of the information you can get, some of the technology you have, you can become really efficient. If you're trying to account for everything, it works a little bit paralyzing, I find.
So I think I agree with I mean, we just got a lot of the perspective from two different robotics vendor. I want to flip it over to the end user side, and maybe Parth, for you, how do organizations like Card.com and others, what are some of the best practices for collaborating with technology providers and other stakeholders to really drive innovation in supply chain robotics? And I think it's interesting that you've been on the technology provider side, selling to the end users, and now how has your perspective changed now that you're on the other side?
180-degree flip, but no, honestly, on a serious note, I think the way we've seen in my past life, specifically from a Card.com, we are still a startup, so there are things that we still are working towards. So not a great example I can share from my current responsibilities, but my previous responsibilities, the way we worked was pretty much doing those proof of concepts or providing a better way for a vendor to come into the business and help us be a really partner in that discovery phase. And that was one of the ways that we have done in past. But at the same time, now coming on the end user side, one thing I'm definitely appreciate a lot, and I always look for, is good partners, because for me and my leadership, we care about shipping orders, right? That's where we are very, very focused on. So at that point, we need good partners who can enable that for us. And so the way I'm always, and that's an end user perspective, that if we have good partners, we are gonna go with them always. But important for us is technology, of course, but at the same time, shipping orders. That is very important as a 3PL for us.
And so Florian mentioned AI, and I think for a lot of companies, they think AI was just invented last year, but it's been going for like 40 years. In fact, a lot of the AMRs use computer vision, use path planning. I think there are some newer techniques like transformers and everything that's happening on the generative side, but also like compute power is getting better, and now you can do inference at the edge and so on. So, Parth, staying with you, where do you see, just even beyond robotics, where do you see AI coming up in supply chain operations?
A lot of places, to be honest. And few things that really comes up my mind is, even though we as an organization, if a warehouse is not using a robot, they're still generating data. They are still using some kind of warehouse management systems or inventory management systems, order management systems that is constantly generating data for them. So the way I look at that is an AI or a nice algorithm can really help them improve their pick path, right? That is the basic. Using your traveling salesman problem, traveling salesman constantly improves on whatever the pick paths there are, and just helps you for every batch of work that is released. You are still using your AI and figuring out the best path forward. That's one of the basic fundamentals that I feel like the AIs or someone comes with a solution which pretty much plug into an API and can get a nice route planning within the pick path would be great. Application also from the packaging side, the cubing is going to be important as well. So looking forward, I feel like there is great potential for the AI and ML within the generative AI and ML within the warehousing space, because as a warehouse, we're always generating data, but the application is where we might have to really figure out which application makes sense, which application is fruitful, as well as is really worth it to solve for. So that's something I think would be a next step as people are looking into this, using this technology and putting on a use case, which is a warehousing use case.
Wonderful. And I'm going to touch on a topic that usually doesn't get discussed as much, but I know Kärcher cares a lot about sustainability and the impact on climate change. So, Florian, do you have any thoughts on how robotics plays into that, how it might contribute to that, to sustainability?
Cool. That is a tough tough question. Well, of course. I mean, I think, we mentioned earlier, coming back to collecting data, a lot of data, and I think that brings us to like making the operations more efficient. I think that's going to have an impact on say sustainability. Of course, also, how much detergent do you have to apply? Those kind of things. You'll spend less time because your path planning is more efficient. Those kind of things. No, that's not the biggest impact, but that's what immediately comes to my mind, where you have a positive impact on the environment.
Yeah, or you mentioned, for example, instead of just cleaning everything all the time, cleaning where it's needed.
Exactly. For me, that goes beyond the robotics. Though, we have also technologies where you can collect data and track movement of people in order to figure out when to clean where, and so increase efficiency, but also experience, customer experience, because you know when it needs to be cleaned, and so whenever people get there, they experience a nicely cleaned space, and of course, that's it. So it's not just the sustainability angle, but also the experience angle.
All right, so this is the mandatory part in every panel, where I ask each of you to gaze into your own crystal ball, right, and look to the future. Let's say the future of supply chain, robot operations. And let's say, the next 5 years, if you want to go all the way to 10, go for it. But, let's keep it to before we get to Mars. And what do you see? How do you see this evolving? Nicholas, maybe we'll start with you.
Yeah, I think I was hoping I could have said something about sustainability. Maybe I'll get back to that later. But on your current question, I think multi-vendor, multi-type robot coordination, working together definitely will be a thing. I think right now it's almost inexistent, but there's a lot of concepts, a lot of people working on it. There's a lot of need. And so with the level of technology today, with companies like yours, InOrbit, I think there's a lot of exciting developments that will make this a reality. And then all of a sudden you unlock new things, right? Because things are not all individual silos. You don't have the floor cleaning robots, the unloading robot, they're not all doing their own little project in their silos. They kind of work like human beings together. I think this is one of those things that is very exciting, because not only does it allow for every single vendor to do more things, it just also allows, more importantly, for the customer now to get to a seamless solution and more productive solution.
So go on the sustainability part, because if we're thinking about the future, we still need a planet to live in for that future to be relevant. And
I'll use very specific things that if I think about the warehouse and if I think about unloading, just because this is a very specific thing. Unloading is something that unloading bulk loaded trailers is something most people want to do. Why? Because that gets them to optimize the trailers, put more in a trailer, less pallet. You can't always stack pallets on top of each other, but they also don't always want to do it because it takes forever to unload. So there's always that balance, because by automating that piece in a productive way, it's one piece of the equation they have to think about less. They say, okay, well, the fact that it's going to take a while when it gets to the warehouse is not really an issue anymore. It used to be an issue. Now it's less of an issue because our automation is going to take care of it. So now I can send less trailers on the road. I can have better packed containers and so on. So that just enables that, and that means just less greenhouse, less congestion, and tons of other related benefits. Less pallets means less wood, which is also not a bad thing. And I think on robotics in general, stuff we do also here at Boston Dynamics, which is not so much, which can be related to the warehouse, more in general. And it goes to efficiency of operations. If you have robotics that can go and inspect all manufacturing lines and help with preventative maintenance, you up the efficiency of your manufacturing, and therefore you have less wasteful machinery, because you just can maintain it better. You have less downtime, less breakage, more optimized run times. And so those are two little aspects, and there's probably a whole list of things you can come up with, but those are, I guess, dear to our heart to make sure they're becoming a reality. And they are becoming a reality. Now we just need to do it at scale.
Yeah, and I think if anyone gets a chance to visit the yard of a fulfillment center, there's usually a line of diesel trucks just idling, waiting for cargo dock to open up. If you can move those more efficiently, then clearly there's a very direct connection. Parth, how about back to you with your crystal ball? What is it telling you?
I use this term a lot. You would have noticed robot for forward warehouses is what I feel like the future is going to be, and I think it ties into what Nicholas was saying, like a lot of different robotics vendors playing into the warehousing space. So for me, still an completely automated warehouse is, at least for me, it's not possible. But for my definition of robot forward warehouses, that there will be a lot of monotonous tasks, the repeatable tasks will be taken over by robots, and real human beings will be providing, being our MVPs, will provide really high skill things that we need them for. So crystal balling is going to be a robot forward warehouses where robots will really help us with a lot of other things, where we can take away people from just doing repeatable stuff.
And there's a lot of debate about, greenfield versus brownfield. Do you think that a robot forward warehouse has to be built to spec, or can we repurpose some of our existing warehouses?
So I think eventually now, as you see the market, and Instock is a good example from today, right? So people are moving towards brownfield, greenfield solutions. We know the famous ASRS solutions, QBSRS solution, does have a higher requirements on flooring requirements, fire safety requirements, stuff like that. And that's why now, as the adoption starts happening, when people are thinking about this different solution, they are running into this adoption challenges. Like, hey, I need to do this, or else I won't be able to put a robotic system I need. And that's where Instock providers like Instock can really step in and like, hey, we can still help you with your brownfield solution with a similar benefits of an ASRS solution.
Great. Florian, your crystal ball?
Yeah, pretty similar. I'm very bullish about the adoption of robots. So there's going to be more, like a bigger number of robots in the warehouses, of course. I'm pretty sure there's going to be new applications that are going to find their way into the warehouses. And of course, also like at least that's a hope, that there's like a better integration, not just between robots, but also like integration into existing processes, integrating with like manually operated machines, operations, and overall like bringing it all together, like fully integrated warehouse. Maybe that's the right term for me.
Great. So I think we want to save a little bit of time for Q&A, but before we go to questions, what is a question that I should have asked during this panel that I didn't, or something that you want to talk about? Again, we'll start with you, Florian.
Well, actually, nothing came to my mind. Like, I think we're like being a cleaning company in the logistic warehouse environment is like it's a different thing, because the only thing that we want to do is like make sure everything is clean and not interfering with like other processes, right? So we like see ourselves there as a support function, again, a very crucial support function. But other than that, I think we are kind of like playing not the key role in the warehouse operations here.
How about you, Parth?
I think we definitely should be thinking about safety and safety regulations when it comes to robots. And I know there are organizations like SME, I think, are already working on those regulations on making sure how robots can integrate within the space occupied by people. So I think safety is something I feel like it's going to be a topic, should be a topic, and must be a topic as we have more robots, as we think about more use cases of robots in a place where people are already working.
Yeah, there's been a lot of work, for example, with ISO R1508 for, I think they're called industrial mobile robots, but basically AMRs and AGVs that move around. Yeah, obviously, in a situation where you have, as you said, people and robots coexisting for quite some time, and robots coexisting now, I think safety becomes really critical and something the industry has to pay close attention. I think we've seen some version of that debate with self-driving cars, which of course is a little different. It's on open roads. It's very hard to control. I think the warehouse provides a little bit more control, but it's still a very hectic and chaotic sometimes environment with people coming in and out, goods coming in and out. So yeah, thanks for bringing that up. I think that's a really critical topic. I don't know, Nicholas, if you have something to mention on safety or any other topics.
Well, I mean, safety is could be its own panel, I think, and maybe with people that are a bit more expert. It is a very important topic. I mean, if you think about what are all the bottlenecks or all the roadblocks to deploy robots, safety certainly. I mean, it's I don't want to talk safety as a roadblock, but it's a technical hurdle that is not trivial to overcome. And safety is important, is paramount, is first priority, so you got to solve it. But between what robots can do and what robots can do safely, there's actually a reasonable gap there. So that's interesting to continuously explore, and that's why I mentioned earlier, like, is there common sense that can help mitigate some of the very stringent requirements. And I'm not saying that's the answer. I'm kind of more like throwing it out there as something that, because it evidently is part of how they look at autonomous car. So to what extent can such approaches be applied to robot? But about your question about what wasn't talked about, and I'm not the expert, far from it, but we didn't really talk so much about the WMS part of the integration towards the robotic solutions, which I understand. I think from a technology standpoint, it's not necessarily the biggest challenge, but from what it takes, what it adds as complexity or cost to a project, can be, I would say, can hurt a business case. Let's put it this way. And so the good news is, I think there's no real technical hurdles here, technology hurdles, but there's ways to do it a lot better, which, I know InOrbit, you definitely are helping a lot with that, and that's great. So that's, this is something that we didn't really talk about through the panel today. So I don't know if that's something maybe the audience wants to talk more about, or.
Yeah, I think just from a lot of conversations with people in the space, the software integration aspect tends to sometimes be overlooked, but it could be the longest part of deployment. If you're not using the right technology, there are obviously some great commercial warehouse management systems and warehouse execution systems, but there's also a lot of homegrown, right? Especially when you go to these larger companies, they may have different warehouses, may have different WMSs, different versions of the same WMS. So it can get pretty messy. And being able to very quickly connect to those becomes critical. Okay, so I think we've covered a ton of ground today. one thing that I really like is, during this panel and even the earlier presentations, how this kind of ecosystem is really starting to come together, and how we need to make all the pieces fit, right? So from an end user's perspective, it's great if you can, let's say, you can automate cross-docking, but that's only one part of your workflow. And if things upstream or downstream from that are not efficient, you're still going to suffer. So I think what we're seeing is this trend, which I think was reflected today, specialization. But then how do we, specialization combined with orchestration and integration, all the Sean's together. So I think that's a trend that we've been tracking, and I think it's a great direction. Let's turn it over to Jeff, who may give us some questions that he's been receiving from the audience.
Yeah, I have a few questions. One actually very specific one that I think, hold on, if I can just find it now, was for Florian. I can't find that right now. I will find that in a minute and I'll come back to you, Florian. Kärcher Florian, that is. Sorry, I have to be clear here. I'll find that one from the audience and circle back to you on that. Yeah, I know, Nicholas, you talked about sort of common sense in the warehouse. Parth, you talked about the robot forward warehouse. Can we talk a bit more about sort of the people ops of it all, integration, of course, how and what are the major sort of relevant concerns that companies integrating automation into their warehouses, especially, what should they be considering when trying to orchestrate people alongside their new automation technologies?
I can lead in a little bit with that. Sure. It's I mean, I could probably talk about this for an hour because it's a real day-to-day thing. So maybe I'll start with some observations we have. Robotics allow for efficiency, productivity, but it shifts sometimes where efficiency is created. So where in a fully manual warehouse, people do work in a certain way. They've probably done it for a while and they kind of got it sorted. And they do the work. Now, do they maximize productivity? No. Do they have a lot of challenges because they need a lot of people? Absolutely. So there's a number of things that come to mind. Now you bring in robotics wherever in the process, and all of a sudden, this goes very well, but you create bottlenecks elsewhere. So that's something that we see very often where, hey, robots work great, no problem with the robot, but we're actually losing productivity. It's like, how is that possible? Like, mathematically, that does not make sense because you just gain somewhere. But it's to actually streamline it, make sure that as you're thinking about your automation, especially if it's going to interact with people, you're thinking full picture and you're thinking full picture early in a project, and you don't get surprised by it, because then you'll solve the problem eventually, but it creates some frictions as you actually have a successful robot deployment, but you actually have something. And I can see how that must have been very challenging for all the big robots around there, because they all of a sudden made people more productive. Where do you bring them? What? And so on. So that's certainly something I would want anyone involved in projects to not overlook early on. It's not too early to start talking about these things. But I'm focusing, can the robot do this? Can the robot navigate this? It's like, well, trust the technology provider that they know what they're doing, but just make sure we have a good operation.
Yeah, that absolutely makes sense. I don't know, Parth, do you have a perspective out on that? I know you were talking about the safety sort of side of it, but that integration is kind of critical.
Yeah, I think for me, it's more people driven, where if we are bringing in robots, people do trust as a buyer, when I'm bringing something on the table or someone else is bringing something on the table, they do trust that the due diligence has been done, that it's going to help solve the problem. But the aspect of the buying that needs to be done is from the people side, that are my people skilled enough to operate it? B, if I put it, will I be able to maintain it? And C, the individuals that I have right now doing the work, Where are they going to be? What can they be reskilled to do something else? Can be the upskill to do the maintenance of this thing, or I need to bring in a new whole team to do that. So I think when we go into any kind of robotics exploration process, one thing is like we solve the problem using a robot. That's great, but then the actual task comes in is about how actually it integrates it and what the people aspect of it, how people are going to use it, and is it going to be a really successful deployment? Because having shipped orders on your go live date, it's great, but then shipping those orders next 2 years is actually real success of that project, not just shipping on the go live date.
That makes sense. Absolutely. Florian, if you want to add anything, please feel free. But I do have that specific question for you, Florian, as well, which is if you could define 15,000 meters squared in a more understandable terms to someone who's not quite as technical. Is it 8 hours of operation or covering a large airport space? How much is that?
Oh, honestly, that's not my field of expertise because I'm not on the product side.
All right, that was probably from
that probably
from earlier.
Would have been a right question for Felipe. Yeah, exactly.
Okay, well, we will get the answer and
Yeah.
send it back to you. Absolutely not to worry. But let's talk quickly about scaling and what that means, because that's, I think, incredibly relevant to the people on this call. People are at varying stages. So we've got people who are really early to market, and then people who are in this sort of growth stage. Florian Pastoni, of course, InOrbit focuses a lot on that transition. We know the challenges, of course, on going from 10 robots to 100 robots, one site to 3 sites. It's a massive difference, and all of a sudden, tools that worked in your proof of concept prototyping pilot just don't work anymore. So when we talk a bit about how we would approach scaling and what people should be concerned about, thinking about.
Yeah, I think what we've seen talking to companies in supply chain as well as other industries. So I think what's fascinating is, this is pervading lots of different use cases. Everyone has some sort of internal supply chain as well. So we're seeing not just 3PLs and manufacturing companies also improve their supply chain. And there are some common elements that we see all the time. So a lot of times early in the scaling, from an end user perspective, oftentimes you start with a single robot, right? So you have like maybe a proof of concept with a vendor. If that's successful, maybe you move to a pilot phase where you're trying to use the robots in production, but it's usually in a very constrained fashion. And I think there's the industry in the past has suffered, especially when AMRs were a new thing, suffered from being stuck in pilot mode, sometimes for years. Which, especially for a startup, it will stretch your capacity to keep up. I think that's getting faster and faster, that pilot phase. And then you start getting to true scaling, and we see 2 different scenarios, right? One is many robots in one location or in few locations, but you also have the scenario where you have many, few robots per location, but many locations. So there's 2 modes of scaling. One is more dense and the other one is more distributed. It's going to depend on the application. It's going to depend on what you're trying to solve for. But I think what we see in general is the things that work in that really early stage. And to be fair, like a lot of AMR companies, when they first deploy a robot, they send, there's literally this role of chaperone, where there's usually an engineer following the robot around. And the first deployment is the most exciting. Everyone wants to fight to be there. once you're like, it's been 100 days of being in the warehouse, maybe you want to go back to your monitor and to your ergonomic chair. So I think it's a challenge as you start to scale. How do you keep up with that? And that's where the tools that got you there are no longer going to help you in your next phase. So for each of these phase transitions, you need to level up your robot operations, how you support your robots in the field.
Yeah, of course that makes sense. Well, I think Florian, our other Florian here, probably has a good perspective on that. You're, if for those who don't know, Kärcher is widely used company across the world, and particularly across Europe. You guys have deployments everywhere, really. How do you manage that, and what do you tell your customers when they're coming to you talking about ramping up a fleet?
Well, we're still at also at the very early stage of scaling, so it's not that we have that many like robots that on site, like at one particular site, but all the robots out there is it's the Kärcher fleet, right? And we have to manage them somehow. So, and therefore we're super happy to have it's not a secret that we're working with InOrbit to have transparency and visibility into all the robots, especially at an early stage. And we all know that a robot is never going to be 100% perfect. So it's especially at those early during those early phases, important to have all these insights, what's going on. So you can at anytime we can see what's happening out in the field, which gives us a kind of a peace of mind to, and also helps us to support our promise to our customers to give them a fully autonomous robot, right? If they're if they would have to go to the robot whenever there was an inception, it probably wouldn't perceived as a fully autonomous robot. And so we're happy to have such a solution to get access at any time whenever we've whenever there's an incident, whenever we want to see something or want to know something. That is definitely helpful at this early stage where we are still in.
All right. Well, that's fair. That's fair. Well, let's sort of shift a little bit from that. I think that translates a bit into talking not quite analytics, but let's talk about insights, business-driven insights that can, what we can learn from our fleet. What do you, maybe Parth, you can address this one. What do you tell people, who are looking at trying to understand what success looks like? What are the real metrics that should be looked at for measures of success? Because I don't think it's clearly not quite as clear cut as one might imagine right away, especially when you're looking at your pilot and potentially moving out of the innovation team into something like a larger deployment.
Yeah, I think for me, a success is very much sustainability in terms of sustainable deployments. When I think about sustainable deployments, is if I'm deploying something as of today, the system should be working 3 years, 4 years, 5 years from now, because that's the key metric for me when I think about any deployments within my network, right? So if I'm thinking of deploying AMRs in my warehouse, I need to make sure they are going to be serving me 5 years down from that as well. No doubt I have to maintain it, do the PMs on it, make sure I'm doing creating the right ecosystem for those AMRs to be successful. But I want that project or that site using robots for the foreseeable future. So that's the primary way I judge any successful deployments. But of course, then we go into the numbers about the KPIs, the UPHs, all that matters for sure. And it should matter because you are investing quite heavy from an investment perspective. But when you look at those productivity gains, you definitely gain a lot. Just if you have the right systems, right? If you have the right data flowing through those systems, you can definitely see a productivity gain to 2x or 3x to 4x, right? You can go from 60 UPH to all the way to 400 UPH in the picking side if you provide the right data points, right ecosystem for those AMRs to be successful. And if you don't do that, that means that robot became an expensive piece of junk, to be honest, in your warehouse where you're not able to use it. On a grand scheme, successful deployment to me means that it has been successful working for a few years now. But on a smaller scale, I have to do things on my end to make those robots successful.
And do you find that with your customers, you have to work quite closely hand in hand to get them to understand how to pull the right insights from those KPIs, or do people come in with a clearer understanding of that?
I think my clients are usually the retailers or direct to customer consumers who are very much focused on serving their customers, right? And that's for right reasons. So the way I have to use the robots as a value prop to them is basically, if we have robots, we can guarantee you this SLA, where you can, within this SLA, you can have a faster order fulfillment, which eventually translate into better customer service for their customer. So using that data from, let's say, 120 UPH an hour, right? Let's say, for example, I can translate that data to go all the way to say that, yes, you will have faster order fulfillment from us because we are going to do 120 UPH on the picking side.
Makes sense. That makes sense. Sorry, Florian, did you have something you wanted to add there? Pestoni, sorry. I see you nodding way.
I always nod when I listen to Parth because I'm always learning from his expertise. But yes. I wanted to mention, I think there was a question that came in as well. That about well, do you want to read it, Jeff?
You can read it. I'm going to pull it up.
Right. So basically, it's asking about success stories with InOrbit deployed for integration and orchestration, mixed fleets of robots, lessons learned, what went well. I think the way I would describe it without naming names is depending on how far along you are in your current operations, your pain is very real when you have different robots that are operating together, right? And we've heard, again, we've worked with companies where they have multiple generations of robots, some, like a couple of decades old, like AGVs. You introduce a new robot, and just that combination doesn't work well. Each robot on their own might be working great, but together, it's not. They don't play nice with each other. So one of the things that, that's like, it all starts with how do you put, all the robots kind of on the same map? And I think a lot of companies, even robotics companies, thought that wasn't even possible. I think now that's become possible. So I think that with a little bit of work can work really well. I think one of the other lessons is, so InOrbit is really a platform, right? It's meant for the end users to be able to create their own missions, create their own incidents and dashboards and everything. And a lot of times they don't actually know what they need, right? They have this abstract notion of, I need data, but to go from there to, okay, and I need this data presented this way at this level of granularity. So I think there's a process that companies have to go through to figure that out. The tool is designed to be self-serve, so you can iterate and experiment on your own. We usually have our team supporting those deployments with our expertise. We'll even do something we call InOrbit Intelligence, which is a way to share our expertise, kind of whether you end up using InOrbit or not. Of course, we hope you will. But really, kind of like sharing all the expertise. We have people on our team that scaled from 30 to 600 robots in 12 months, which is pretty brutal. And just being able to share that expertise also allows companies who maybe aren't quite there, like they're thinking about how they're going to do it. And they want to do it right. They know they're going to have multiple robots. They know they're going to need some form of orchestration. help them anticipate the problems that they don't yet know they're going to have. So I think that's also very, very useful.
Yeah, absolutely, absolutely. I think we're running low on time, but let's get a quick last word in from everyone. Nicholas, I know, speaking of growing quickly, that and especially on the sales side, I have a personal interest in this, of course, kind of working on the marketing side, but like the public perception of BD is, people have a lot of opinions coming in. Is there any misconceptions, or is there anything that people are first asking you when you're coming into those conversations that you need to set them straight about?
I think the company has been around for a while, right?
Yeah.
And I think one thing that we want to make sure people understand that, yes, we've been developing technology for a long time, but if you think about it as a commercial company, we're 3-year old. We're young, and so that's something that we're not shy of saying that. I mean, it's a reality, and that comes with its opportunities, it comes with its challenges, and I think when it comes to scaling, I think Florian mentioned, everybody mentioned it earlier. I mean, making sure you have the right ability to support and service is something that you build, and something that takes a little bit of time. So that's something that we're in the process of. Asking about misconceptions, the one thing that I find to some extent that quite maybe surprising, or maybe it shouldn't be, but there's still a lot of people think that we are very active in military-related projects, while we actually haven't touched any of those for at least 10 years. I mean, that's our legacy. That's how we started. That's how a lot of technology was built. But as a company, we are a commercial company looking at industry, looking at warehouses, and those are our focus points. And just maybe that's a small group to make that point come across. But that's something that still is a conception, I guess. I don't know if it's a misconception because there's a history of it, but it is definitely not the current reality.
No, that's great to clarify that. I think that focus, and I think everyone on this call certainly appreciates the work, and can't watch those videos of Stretch and not be thoroughly impressed. I mean, I think everyone can agree on that point for sure. Florian, do you have any final notes you'd like to add about Kärcher and anything you wanted to wrap up with?
Sure. I mean, it's actually funny, but for us, it's actually the opposite, right? We're incumbent in of the cleaning industry. We've been around forever, and probably one of the best in the world when it comes to cleaning technology. But how is it possible that such a company can build a good robot, right? And as Philippe mentioned earlier, it's all our fully owned IP, and I'm confident I can confidently say that we have one of the best robots in the field. But I think with our customers, we first need to build up this credibility. So we need to go there, do a POC, as Parth mentioned at the beginning, show them that our robot can not just clean the floor, but also drive around properly and safely in particular. And so yeah, I think that's times are changing. The robotic is gonna be a crucial technology in the future for the cleaning industry, of course, with all the the trends going on, especially labor shortage here. So yeah, exciting times for us, and I hope we can build up this trust with our customer, improve that we also not just a cleaning company or provider of cleaning technology, but also a technology company and provider of solution that goes beyond just the cleaning.
For sure. Well, yes, you're right. We definitely live in interesting times now. Parth, any final words before we take our leave? We've got about a minute.
No, I think this was great. Thank you for putting together. I think I learned a lot, to be honest. I think I'm gonna definitely reach out to a lot of people here on LinkedIn, because I think it's always good to be connected with smart people, learn from smart people, right? So thank you for your time, and I really appreciate all the insights. Yeah.
Cool. Well, Florian, did you have any final words you wanted to say before we wrap up?
I'll just say it takes a village to run a warehouse, and I think seeing everyone coming in and talk about their part in this effort is really fantastic. That's very much the spirit behind InOrbit Connect and actually the robot space. So I would just mention anyone who's in Silicon Valley and wants to come and geek out with robots, you're welcome to stop by.
Okay, with that, we are going to bid you all a fond farewell. I'd like to thank, of course, all of our panelists for being here. It was a really engaging, interesting conversation. And all of our exhibiting companies from earlier, thank you so much for joining in with the InOrbit Connect Live event. As a reminder, you guys can all feel free, any attendees, reach out to us, and we'll be happy to connect you with any of the companies that we're presenting here today. And otherwise, we'll thank you very much for your time, and we hope you all have a great rest of your day. Thanks so much, everyone. We'll see you next time.
Thank you.
Bye.
Thank you.
Thank you.
Bye-bye.